Hi, I'm Janine Cody, Director of the Chromosome 18 Clinical Research Center, and I'd like to demonstrate the clinical utility of our gene dosage maps, and which in turn demonstrate why it's so important to have a molecular diagnosis. So I'm going to share two examples, and our gene dosage maps are located on our website here. And I hope you'll read the instructions for how to use them, and there's another YouTube video that you can look at that explains how to use them. And so some of the images I am showing will make more sense if you have looked at that video first. So I'm just going to show partial screenshots from our gene dosage maps. So once you understand how the maps were created and where they come from, the images I'll show you will make a little more sense. But let me show you two examples here. In this case, first example is a person with a 5.5 megabase deletion of 18q. It's a terminal deletion. Here's an ideogram of chromosome 18, and there's a red box around the end. And so the red box right here is the region of this deletion. Here's the exact base pairs right here from 72.6 megabases to the end of the chromosome. And so here is the viewing window, or a zoomed in view of what's contained within that, what's shown in the red box here is zoomed in right here. And this image has three parts. At the top are the UCSC genes. So this shows every single gene in this region of chromosome 18. Below that are the genes in our clinical hemizygosity map. So this is the gene deletion map. So the classifications of just the genes that we think have clinical consequences when you have a deletion of them. And the bottom section are the phenotypes associated with a deletion of this region of chromosome 18. So in these cases, we don't know exactly which gene causes the problem, but we have it narrowed down to 5 or 6 or 10 or whatever genes. We just don't know which one. But it is important to know which problems are associated with this part of the chromosome, even though we don't know exactly which gene. So what you can do with this then is to look up all the genes that have clinical consequences. So you can see, for example, here's a gene and here's another one. These genes here are not shown down here because we don't think they have any clinical consequences when you have a deletion of those genes. So this view just shows the ones you need to worry about. So, for example, here is the T-shirt gene, TSHZ1. If you have a deletion of this gene, you have a 78% chance of having stenotic or atretic ear canals. If you have a deletion of this gene, also color-coded pink, means more than 50% chance of an issue related to a deletion of that gene. In this case, it's related to high-frequency sensory neural hearing loss. This particular gene is color-coded green because it's just a risk factor for scoliosis. So we think there's a very small chance, probably other genes are involved or certain conditions are involved in order to have scoliosis because of this deletion of this gene. So other genes on other chromosomes also need to have issues with them. These genes are color-coded purple because those are conditional. These two genes cause recessive conditions. So someone with a deletion of these genes is not going to have these conditions. A recessive condition requires mutation deletion of both copies of the gene. And this person with a deletion just has a deletion of one copy. However, the remaining intact copy could have a mutation. And in that case, you would have one of these conditions. But we think these are only likely to happen in less than 4% of the people with a deletion. So this is why these are conditional. There's one other factor involved, but they're still very low risk, but not zero risk. So we want to make people aware of them. So those are the genes with potential clinical consequences. Now, there are many regions where we don't know exactly the gene, but we do know specific regions. So The low penetrance, so the ones likely to cause a problem 50% of the time in someone with a deletion, are shown in orange. And those are listed right here. You can click on those to get more information on a secondary page. But those are the orange ones, the low penetrance ones, are IgA deficiency, congenital heart disease, kidney malformation, etc. So you can click on any of these and learn exactly what they are. The regions associated with a problem in more than 50% of people are shown in pink. And you can, again, click on any of these to determine what they are. So here's mood disorders right here. We have delayed myelination, growth hormone deficiency, and palate abnormality. And as I said, you can click on those and learn more about it and determine the references, scientific citations we use to determine that. And by way of an example, here is a person who actually has a deletion of this region of chromosome 18, just to show you an example. And this person's IQ is 120. They are hearing impaired. They have atretic ear canals and a foot deformity. They're growth hormone deficient. They have dysmyelination of the central nervous system. And they have executive function difficulties, meaning they really have trouble organizing their day and their life and getting from point A to point B and solving problems in what most adults would consider trivial problems of the day. So there are some difficulties, but this individual has a higher than average IQ. So this is one example of how this specific deletion manifests in one person, and the clinical information that you might know in advance what to look for and think about. So another example, here is another person with just a slightly larger deletion on chromosome 18. As you can see from the red box, it's an entirely different region of chromosome 18. It's because I wanted to show you that entirely different region is associated with entirely different things. Again, this view of this region has all the genes in the region. So here they are. Here's some little genes, bigger and bigger genes. Here is DCC, a giant gene. So here's all the bars that are connected. This is the biggest gene on chromosome 18 and one of the biggest ones in the human genome, actually. Below that are the genes in the region and phenotypes in the region. So the, for example, here's purple, which are conditional, associated with autism, for example. Then there's a green one, so that's just a risk factor. So it's found deleted more often in people with autism than people without autism. So it is a minor contributor. The genes shown, for example, in the low penetrance are orange again, and so this gene, DCC, is associated with congenital mirror movements, but we see that in less than 50% of the people with deletions of this gene. The higher risk things found in more than 50% of people are this gene SMAD4, which is associated with polyposis of the stomach and duodenum, and this gene TCF4, which is associated with Pitt-Hopkins syndrome. So these are the genes in the region. You can click on those to determine exactly the information about them. There's only one phenotype region. So this phenotype, Dandy-Walker malformation, is associated with one of the genes in this region. In fact, you don't really know how much further it goes out of the view of this particular window. But is associated with a region, but we don't know yet which gene. So, but it does help you narrow down a little bit the issues here. So, this particular person at age 3 had a developmental age of 6 months, even though they were 3 years old. And at age 10, they were not yet walking, talking, or toilet trained. They met the diagnostic criteria for autism, and they had the facial features of Pitt-Hopkins syndrome. However, they had normal hearing and normal ear canals. They did not have growth hormone deficiency or delayed myelination. These last three things are all associated with the deletion of the other end of the chromosome. So if you know specifically that this person has this deletion, you know that just monitor their growth by monitoring their height, but they're really not any more at risk for growth hormone deficiency than anyone in the general population. They should have their hearing checked, but they're not at high risk for having hearing loss or trigeminal canals. So that's how knowing the specific deletion can help you hone in on what are the most likely issues, and also eliminate those things often associated with 18q deletion that aren't relevant for this particular person. So that's where we're going. We want to understand exactly which problems are associated with which deletion, and ultimately, what are the treatments associated for having a deletion of that specific gene? Or, in other examples, duplications of other regions or deletions of other regions. These are just two examples. You can pick any two examples, and we could show why the molecular information is beginning to reveal much more and give you more insight, and eventually it will point to very specific treatments, because our goal is to make the chromosome 18 abnormalities the first treatable chromosome abnormalities. And with your help, we'll get there. And if you have comments, questions, concerns, ideas, please contact us. We want to hear from you. And the responsible party to contact is Annis Hill. She's our program manager, and she will determine if your email is for me or for someone else, and she'll get it to the right person, since we have a big team of people working on this. But more importantly, she will bug us until we answer your email. Most of us get so many emails that it's hard to keep up, and sometimes they get beyond the bottom of the screen and I forget. And so Annis won't let me forget, and we'll get back to you. And we thank you so much for your interest in chromosome 18 and people with chromosome 18 abnormalities. Thank you.